Welcome to my fourth video covering my Unity development. Previously, I talked about how although progress was being made on the game, there wasn't really a solid design plan or a high-level to-do list in place, and things were kind of being added as I went along. So in this update, I'm going to go over the architecture rework that I did and the high-level approach I'm going to be taking. The game is made up of entities, and entities can be anything like the player: a structure, an agent, a weapon, a projectile, so pretty much anything. In my original approach, I created a C# script for every new entity that I wanted. Most of the time, this C# script was completely empty and just inherited from its parent. I then attached this script to a new prefab, which represented the entity. Now the issue with this approach was that I was treating data like normal C# scripts, and so I had to create unique prefabs and scripts for each new entity. So the key thing here then for me to refactor is the fact that I'm mostly changing data rather than behavior. Unity provides a solution for this through scriptable objects. Scriptable objects make it easier to swap data in and out, and it reduces memory usage as it allows you to store data in one unique place which can be referenced from elsewhere. The approach I ended up taking with scriptable objects is as follows. Each entity is split up into two parts: the entity script itself, which is attached to a prefab, which is essentially what gives me unique instances, and an entity definition. The entity definition is a scriptable object asset which does two things. It holds the data for a unique entity, such as its name and health, and it executes custom behavior. The entity script, which is kind of a container for the entity definition, simply then delegates entity logic and behavior to this entity definition. This approach is really nice as it makes it extremely easy to add and remove entities, and it makes much more sense to create and store them as assets rather than mono behaviors. In terms of a high-level overview, I know that I want the following systems in my game: an AI system for enemies and player units, an item system for weapons and other equipables, spawners and a wave system, and a structure system so that players can place things like walls, towers, and traps. I also like the idea of having an RTS element in this game, so in a later iteration I'd like to try adding structures that spawn workers which can work on things like farms, but this will have to go through a lot of playtesting to make sure it's an enjoyable feature. An important thing to keep in mind is that having a completely fleshed out, top-level overview of the game isn't always handy. As I continue to playtest and iterate and start to get other people to playtest, aspects of the game might change a lot. Maybe some of the core systems that I have in mind now I won't need later on. Or maybe one specific system or gameplay mechanic is really popular and becomes the core of the game, and so focus shifts to that. With this new architecture in place, I started work on two new systems which you've been looking at for the past few seconds: a very basic spawner and AI agents. The AI is quite crude and uses Unity's nav mesh components. It either seeks out the player or the tower at the center of the map, whichever is closest, unless the AI is close to the tower, in which case it'll prioritize that. If it can't reach the player or the tower, it destroys whatever's blocking it. The spawner itself is quite simple. It spawns a set amount of enemy agents and keeps a record of their references. Whenever an agent dies, that agent emits an event containing a reference to itself, which the spawner listens for. The spawner then checks if this agent that's died is within its own record. If it is, it spawns a new agent. For my next video, I'm going to be fleshing these systems out a bit more, improve the character controller, introduce effect entities for traps, and add ranged weapons. I hope to soon have a complete bare-bones playable game so that I can start focusing on how I want specific mechanics to influence gameplay. And that's everything for this video. Thank you for watching.